For the people joining, hi, and for the people that are going to watch it on YouTube, also hi. Today we say thank you to Dr. Matthias Aßenmacher for taking the time to talk to us. He's a postdoc researcher at the SODS chair in the statistics department at LMU, Munich, and the BERD at the NFDI Consortium. He finished his PhD with a focus on NLP in 2021, and he's also a co-founder of the Open Science Initiative in Statistics. And today he'll talk about open source teaching resources in NLP. And yeah, thank you very much.
Yeah, thanks a lot, Martin, for the nice introduction, and thanks for also inviting me, Philip. Today's talk is going to be somewhere in between, I would say, a shameless advertisement for our teaching resources we're developing in an open source manner, and also somewhat in the direction of an advocacy for doing stuff like this, because I'm also, as Martin said, I co-founded the initiative, the Open Science Initiative at our department. I'm kind of a big advocate of doing things open source, open science, and bringing stuff to the world and sharing stuff. This presentation, oh yeah, I'm not sharing my screen yet. Good point. Now we should be able to see it, right?
Yes.
Perfect. And this is not entirely my own work. So it's on the one hand side, the open source NLP course we're developing at the moment is joint work with my former PhD supervisor, Heumann, Leonie Weisweiler from CIS here at LMU, and also the guys from Vienna, Ben Roth, Aaron Chano, and Andreas Stefan. And part of the slides is also has to be attributed to Ludwigs, who is the guy at our chair who was responsible for developing the Introduction to Machine Learning course. Also in a similar manner, he and colleagues wrote also a paper on arXiv about this topic, specifically about developing these open source educational resources. And he kind of generously allowed me to take some of the slides. And this deep learning for NLP part is only the thing we're working on, but I'm going to start by introducing the I2ML platform, which is kind of the big thing we're kind of trying to catch up to, because they are developing this for several years now, and it's far more advanced with respect to what's on there than our platform, but we're trying to get there at some point in time. Then I'm going to quickly go over some important points of the paper from Ludwigs and colleagues, and then finally arriving at what is happening in NLP at the moment, and why is it necessary to probably have such an open source educational resource. So the I2ML platform was developed by people from our chair, and the basic concept of it was to have a very, very modular design. So they do not have lectures like full length on there. It's always smaller chunks of YouTube videos alongside with slides, additional material like exercises, and so on. So to make it really digestible in a compact manner for the students and all the people who are interested. What they also added are interactive elements, like they are teaching this at LMU regularly, I think every second semester, in an inverted classroom style. The website also contains quizzes on there. They are implemented with QuizDown, which give direct feedback to the user. The target group of this course was initially, or are still, bachelor students from the Statistics and Data Science program. And we had some kind of a makeover of our bachelor this year. And now machine learning is more a part of it than earlier, but basically this might be the first contact of some students with this material, like with ML in general. But also master students in statistics and data science can use it in the master's program. Obviously, they don't start fully from scratch, but they rely on basic math fundamentals on university level, like what should be learned by everyone in the German high school, stuff like linear algebra, calculus, probability, statistics, and also probably some basic programming experiments, either in R or in Python. And yeah, this is what this course is about. It's basically, on the one hand side, is this clear and plain introduction to machine learning, talking about stuff like risk minimization, distinguishing between regression and classification, talking about evaluation and resampling, tuning models, and then a small stack of models that are introduced, most of them classical machine learning models, or also classical statistical models like logistic regression, which explains also in some to some extent why we need some deep learning course, especially for NLP. The supervised learning, the second part of the course, is also on the website, but not taught within the LMU course. It's more about learning theory, information theory, how to regularize models, and also some more advanced models. There is also a separate deep learning course developed by people from our chair, which is covered in a separate lecture. Plus, we're doing this specifically for NLP also as well. This is how it looks like. The design on the left-hand side is basically this, because we adapted this design, it's basically similar, or looks kind of similar to our homepage. In the middle, you can see how the slides look like, and then on the right-hand side, you see one example of the YouTube videos, which is, like Bernd, Ludwig, and all the guys put very much effort in recording proper videos into this, and it's really worth watching, I would say, for beginners in ML. But this platform also comes with exercises. On the left-hand side, you see the exercise sheet. In the middle, directly the solution, which is also available on the platform. I'm sorry, let me quickly turn off my MetaMouse so the things don't annoy us. Yeah, sorry, now it should be silent. And on the right-hand side, you can see the aforementioned quizzes. Like you have these multiple choice blocks where the user can click on something and then gets immediate feedback which of the statements is right and which one is wrong. Furthermore, this platform also comes with code demos showing how the methods or some nice visualizations of the results are implemented in R. It comes with cheat sheets, which is, in my opinion, pretty important to have some unified notation all over the course and not have some notational differences screw things up. Okay, this was kind of our role model for the deep learning for NLP course. And now a few words about Ludwig's paper. It was about specifically developing open source educational resources for machine learning and data science. I really highly recommend reading this paper. It's really interesting, talking a lot about teaching and creating resources in general. There's a link in the slides, but I guess I also can share the link later if people are interested. Or you can just Google for that paper title and we'll find it on archive. And the most important point they make in their paper is the distinguishment between these three types of online courses you see here. But first of all, they make the point that publicly funded teaching material should also be publicly available, which, yeah, on the first side, I guess makes sense to all of us. And most of the courses, at least in my experience, we find online are these MOOCs, massive open online courses. But how is it done there? I mean, some of the courses are freely available in total, but some of them only allow you to use some of the material to limited extent. And there are things like data camp or whatever would then charge you with fees for taking the courses. And this is kind of the counterpart what we're trying to do here. And we're not satisfied with only providing open educational resources, so missing the S for source, because OER is just a course that is freely accessible and free of charge, but basically only the PDFs or videos. What OSER, so open source educational resources, are all about, to share basically everything, every source file, be it a text file, RNW file, videos, slides, exercises, whatever, everything open source available so people can reuse it, or we also want to encourage people to reuse our material. Because it's basically inefficient to not do this, right? If some other teacher at some other university or wherever wants to develop some new machine learning course from scratch, it's basically inefficient if he does it from scratch. It most probably will lead to less qualitative teaching material, and it's probably also not so much fun to write up everything from scratch, right? On the other side, if we go back one slide and look at these MOOCs or OER, taking just one other's material without having the ability to modify something is also not a good idea, because it's basically this take it or leave it approach. You have to take it as is, or you have to leave it, or you have to put an extra effort, like to rebuild the slides in your own template and so on. And that's also, yeah, might be frustrating. Yeah, if we provide people with everything, so all the source files, they can basically easily adapt it to their prerequisites or to their teaching concepts at different places, at different universities, without any effort. Why collaborative? I mean, we started this thing here, but then Ben from Vienna came back into it. It's hard to always keep everything synchronous, to keep communication up, to talk to people, to keep the development going. It's a lot of work, but I guess it's, at least at this point in time, I would say it's worth it. The core principles summed up once again, we do this all collaboratively via GitHub. Someone from our group built this website template, which all of our courses are using at the moment, which is also can be used by other people as well. We have all source files on there. Everything can be modified by people. The licenses are free. We try to always have version releases, so including change logs to allow people to see what changed from this winter term, I don't know, 21 course to the winter term 2022. We try to provide clearly defined prerequisites and learning goals in order to manage the expectations and also tell people what they should know in advance. It should be very modular, like we have small and very, or hopefully well-defined chunks, which allows also lecturers like us or also other lecturers to pick out tiny bits of our material, of our lectures, of our videos, because the smaller the pieces are, the more easier it is to kind of use it as kind of a library, quote unquote. And this, in the second step, also allows us to separate everything that is theoretically and about the methodology from programming exercise or programming related stuff. Right, and this allows a variety of different uses of our material, because everything, as I said already, is freely accessible and modifiable. One scenario could be another lecturer just wants to use it as is. He can just clone the whole thing or use the website. Yeah, partial use is also possible. We actively, and this is one important point, also encourage people to contribute to our material, to make the material better, to improve it. This can be obviously done via pull requests. Same thing for additions. If someone feels that something is missing, can also be easily done via pull request. And if someone wants to modify it in a bigger way or do independent changes to the course, he can just fork the repository. Now that was more about the basics again, and now I'm trying to motivate why NLP, or why it feels to me that NLP needs such resources. Like we had this big change, and as we see in this timeline in 2013, when the word-to-vec framework was introduced. And this is, I think, something that most of the students, when I teach it to them, still get very quickly. It's not super hard to understand. The network is still not super complicated. The self-supervised objective is also pretty straightforward. And this is oftentimes, yeah, one of the starting points for the NLP courses. I mean, sometimes you have beforehand even some bag of words based approaches you introduce, or also the machine learning basics they need to know. But this is kind of the first important milestone, in my opinion. And then I added to this timeline here all the different transfer learning models which came over time. Which is not mentioned here is like important steps like encoder decoder 2014, and the attention paper by Badenau and colleagues, the attention is all you need in 2017. But there are quite some nice time steps where you can really motivate the historical development of what happened. And then, like, one of our chapters is all about transfer learning, starting with ULMFit in 2018, followed by ELMO, which is still, I by chance just gave the lecture on transfer learning plus ELMO and ULMFit this morning. And I had the feeling the students were still quite well able to understand all this, how it fits together with the LSTM, bi-LSTM networks, how this works, what is feature-based transfer learning versus fine-tuning and so on. But from there on, you kind of have to be very careful and maybe put things into little boxes, like distinguish clearly between decoder-based approaches like GPT, encoder-based approaches like BERD in 2018, and so on. But I will show the course structure later. Then we're having this one, streamline of research on oftentimes also called BERDology, where BERD is the new core center part of this streamline of research. Researchers are all about improving BERD, making it more efficient, making it smaller or cheaper. Approaches like Roberta, Albert, Distilbert, all of this will kind of be covered in our, or is already covered in our course. And then we kind of try to take also another turn, but not only looking on the models or looking at the models that build up on BERD, but also looking on the other models that, like GPT-2, ExcelNet, T5, Electra, either choose completely other architectures like T5, which uses the complete encoder-decoder transformer, or really different objectives like the PLM objective from ExcelNet. I'm trying to put this also in another stream of the lecture where it goes. And this was, I would say, only the tip of the iceberg or what is currently happening. We have all this buzz about fuel or zero-shot learning with always larger and larger models up to hundreds of billions of parameters. We have this huge field developing at the moment on prompting and prompt tuning. And it feels like every day there's a new paper out there talking about prompts and prompting zero-shot learning and so on. Another big issue is multilinguality and cross-lingual learning. There was some nice focus on this year's ACL, was on underrepresented languages and how to better incorporate them. So this is, I think, an important issue we should teach the students about. One thing that gets more and more attention in research is bias and stereotypes and mitigating them in language models. But on the other hand side, I have hardly seen any lecture covering this and really making the students aware of this problem. To be honest, we haven't also until now. I had some thesis supervised on this topic, but nothing in the lecture yet. And this is also, but when doing the slides, I actually thought to myself, oh wow, this is something we should definitely change and add this as some of the further topics to our lecture. Another thing that I feel might become more and more important is active learning, especially for NLP. In general, I guess this active learning does not work too well yet with deep models, but given the fact that labeling is very expensive and labels are scarce partly, this might be an important direction to have a look at for research on the one hand side, obviously, but also to tell the students about that this kind of exists and this is kind of important. Plus also multimodal applications. I mean, basically everybody is familiar with stuff like Clip or DALL-E 2, which are in everybody's mouth at the moment. And it's also, I guess it will be a challenge to include this suitably in the pure NLP course. We at our department also had a course over a seminar over the course of the last semester, where we kind of learned about this together with the students. Another shameless advertisement, we wrote a book about this topic. Philip, one of our hosts, is also part of this book, which we're going to publish soon. So might be also maybe a good starting point for some other people to start with this topic. Really nice seminar papers written by the students. And all these, I mean, I could continue this list on and on, but the basic motivation is that we kind of feel that we need to provide the student with a solid foundation to understand all of this to understand all of this, what is going on at the moment. I mean, you cannot tell them all about cross-lingual learning or all about future learning. But the point is to give them some solid fundament to start from when reading up the papers of the current conferences. Because there's also another issue, there's always more and more stuff to read up on, right? There is this nice GitHub repository which collected, I actually don't remember the exact name of the repository anymore. It just collected the numbers of submissions, accepted papers, acceptance rates, and so on. And I kind of took their data it is more on general AI conferences, but I just took the data out, changed some stuff, and then just plotted it for the NLP conferences, for the 4 main conferences actually. The one light gray thing here you see is the EMNLP findings graph, which just was introduced in 2020. So this is why it's not longer. And the acceptance rate are also not the major thing here on the left. It seems interesting that they seem to be slightly increasing, but also we shouldn't be surprised too much given the huge numbers which are kind of exploding for all of the conferences. Like we're coming from something like between 500 and 1,000 for all of the 4 major conferences in 2016, and now we're now even the smallest one of these 4 conferences in terms of submissions is above the highest one from 6 years ago, and the other ones are like 2,500, which is kind of 2 or even 3 times the size they were a couple of years ago. So this is kind of extreme. This growth, I guess, does not only hold for NLP conferences, but for all machine learning, deep learning, computer vision, also related conferences. And yeah, as people need to read all this stuff, they once again need this solid knowledge of what they're reading about. So this platform is designed in a similar fashion as the I2ML platform. We also adapted this modular design and try to foster self-study. We did not yet record videos. We're planning a greater makeover over the next summer, going over the slides again, chunking them even more down to smaller pieces, recording videos. What we're also trying to do already is add good additional material, like adding the literature, the papers, according to the chapters, but also good blog posts, not in an exhaustive manner, like providing 10 blog posts per chapter, but selected 1 or 2 very, very good resources, which really help the people understand stuff. And these interactive elements like quizzes are obviously also planned in the future. Our target group at the moment is twofold. I'm sorry for the computer linguistics guys, did not put them on top, because until 2 years ago, this was a pure compulsory module for the CL study students at LMU. And then Christian and me, basically, we joined forces with Leonie Schütze and guys from over there to also make this possible for our students, because we had the feeling that this is a topic that is growing in importance, and our students until then had no opportunity to hear anything about this. We did a couple of seminars on this, but no lecture on a regular basis. And now this course is basically open to all the master students from statistics and data science, as well as to the students from our elite master in data science. And obviously for us, it's an elective module for our students. For the CL students, it's a compulsory module. Plus, we also have several other people in there. I guess a lot of computer science guys also joined our course. And on the other hand side, we have the guys from Vienna, like Ben Roth, who is now a full professor at the University of Vienna. When back in the days when he was a lecturer here at CIS at LMU, he kind of started this course, which is why what is nice that he kind of came back and we joined forces again. And we're now developing this course together with his people and himself for the computer science and data science students in Vienna. This is basically how the website will look like. I also posted the link at the very bottom of the slide. Yeah, this is basically just to give you an impression, because it's you can read up on all this stuff when and if you click on the homepage. This is, as already mentioned, the people behind this project who are together trying to make something nice possible. It's all of the collaborators are there in alphabetical order. Christian and me, we are the guys from the statistics department here at LMU. Leonie is a PhD student at CIS. Ben, as I already told you, is a full professor in Vienna. Ariel has a postdoc there, and Andy is working there as a PhD student. And yeah, Ben kind of developed the initial version of the course a couple of years ago. Christian, Leonie, and me, and also others like some former PhD students were involved, Hinrich Schütze as well, and so on, but too many people to list them all here. We extended this course because of obvious reasons, I would say, because things happened in the meantime. Like I guess when Ben left, it was 2018-19, so BERD had just appeared, but all the other stuff that came afterwards, he could not have this already covered because it didn't happen yet. And then we kind of met back at this year's ACL and decided to join forces and to create this in an open source manner, which would then allow us, of course, to teach it independently. And this is the very nice thing about we can teach it in our own speed. I mean, we're having this course here at LMU, like for the CL and for the stats students, and Ben is doing his thing in Vienna. We're kind of collaboratively working on improving stuff, but it can be taught completely independently, independent exams, independent quizzes, exercise sheets, and so on, but one single course. And this is what the course is all about. The first 3 chapters are about, I would call it getting all the basics right. Get all people on track, talk about ML basics, classification, regression, how to evaluate the models, and also something about Python, because at least for our students, I can say in the bachelors, it's mostly R that we teach them, which is still the probably more important programming language for really statistics, not machine learning in general. That's debatable. I mean, there are great packages in R like MLR3 and so on, but probably the more we go away from classical ML and so on and statistics in the direction of deep learning, the more important Python gets. But this is basically not one of the core qualifications of our bachelor's degree, which is why one challenge is always to get people on track with Python to understand everything. Second chapter goes exactly in this direction I just mentioned, more from the classical machine learning basics over to the basics in deep learning, like how are deep networks optimized, what are deep networks, what is backpropagation, and so on. And then heading over to advanced neural network architectures. I'm going to talk about tokenization, about word embedding system, the foundation of everything. Shortly also, for completeness sake, about CNNs, which are, to be honest, not so super relevant, I would say, at least for NLP. And then about RNNs and finally attention for having the basics. Extending then the basics by really, this is the session we had today, talking about transfer learning, really to motivate people, to tell them what it is, why we're doing it, why it helps, why it's useful. And also introducing the 2 of the earliest transfer learning architectures. And this might not seem purely obvious why we chose this ordering. I mean, one could also argue that the transformer probably should belong to these advanced neural network architectures. But we chose to do it this way because of timing reasons. We had the feeling that coming from these RNN-based models that were described earlier, then introducing first the concept of transfer learning at all, and these early transfer learning models might make the students better understand the huge impact that the transformer then had and why transfer learning kind of exploded afterwards. And then it's the currently most important stuff, starting with all the architectures that are based on the transformer. GPT, most importantly BERD, as the fundamental turning point, I would say. And then you're kind of splitting this up into BERD-based architectures on the one hand side, and all these, we call it post-BERD architectures in order to kind of distinguish it from the BERD-based. And then we can, can again distinguish between encoder-based architectures, decoder architectures, and the ones taken both like T5, T0, fully encoder-decoder architectures. And here's where we add for the advanced topics. We have some chapters on talking about few and zero shooting and prompting, and another chapter on multilinguality. This is kind of where we are with the advanced topics right now. But you still see that there's a chunk for further topics at the very bottom, which we will be hopefully filling with some more chapters over the summer and also some more over the future. And here's obvious to say that we're always open for collaborations on extending this, making stuff better, adding stuff. Yeah, obviously, to conclude this talk, there are for sure challenges and costs that come with doing this stuff. One thing, I wouldn't say I learned it the hard way. I think I kind of had a clear thought about this from the very beginning on, that we would need quite some amount of communication to get things right, to get things consistent, to kind of take one technical setup that fits all, and then it's kind of also integratable with our share internal system. You have to really clearly possibly adjust them, but once and for all define workflows. How are things developed? How about the different versions? Who works in which branch and so on? So it's kind of, a lot of communication. We are building this upon existing material, so we had to really chunk things down from whole lecture slide decks to these mini slide decks of like 10 to 15 slides. This might maybe be the point where it's on the one hand side easier to build this stuff from scratch, but on the other hand side it was a great made things easier to have something in the very beginning, especially since we built it ourselves. And here are some, if you're interested in some discussion, here are some discussion points we could talk about. Maybe someone else also has experience with collaboratively developing teaching materials. What's the crowd's opinion on having this permanently publicly available? And most importantly, another point I'm also kind of scratching my head about at the moment: what are really the pros and cons between videos, having these videos on YouTube or on some other streaming platform, whatever, and in-person lectures, and how could we best integrate the best of both worlds? Because I guess both really have their advantages as well as severe drawbacks. And I would say I for myself haven't figured perfectly out yet how to do things. So maybe also an interesting discussion point. And with this, I would like to conclude. Thank you for your attention. Thanks for having me, and looking forward to questions and discussion.
Thank you. Thank you. So if anyone has any questions, they can either unmute themselves or just write them in chat.
There is something in the chat. I saw it popping up. Okay, Philip just posted the link. Okay, you two posted some links. All right.
But I have a question, or maybe some idea about videos and in-person lectures. Maybe some kind of a commenting system might be useful for videos and for the slides to discuss problems or some open questions.
You mean adding comments to specific time points in the videos?
Or generally to the page where the topic is presented on.
Mm-hmm. I mean, this can also, this can obviously be done by doing pull requests to our website GitHub repository. This will be one option. If you're not fine with anything of the content or feel that something's missing, you can just write some issue or pull request or whatever. This would be possible there. Oh, did I miss your point?
More for the students, if they go through the slides and they find something which is not clear enough to, and then having a discussion underneath the YouTube video or the slides, like Discuss, I think it's called Discuss.
So there is a tool for this.
Pardon? Yeah.
So you mean there is already some existing tool for having this?
I think so, yes. So it can just be embedded, and then you can write some comments and problems.
If you have some link to this, I'll definitely look into this once we record videos and upload them to YouTube. That's basically the first important prerequisite. But then, sure, some additional tool making things easier and easier to discuss stuff is definitely important.
I've maybe to your second point, because do you think that open source teaching or just open materials in general are the way forward for teaching? Because, for example, with universities like Stanford, MIT, or Jan LeCun himself presenting at NYU and making the videos and materials open source, is there still a benefit to staying closed source, or can closed source teaching stay competitive in this regard if people just go for other materials instead?
I hope that it will be the way forward in the future, right? Because as you say, if the most important universities and researchers already start doing this, why should we stay behind and then keeping it behind some bars artificially? I mean, this is, but as you mentioned precisely the examples of one specific discipline. I guess this is not very common across all research areas. I still encounter sometimes when I talk to students who I'm teaching in kind of the lower semesters, I still get told, hey, this and that lecturer, he does not even upload the slides. So I guess we have to,
okay,
from over there to over there, there's everything out there in university teaching. And I guess for some disciplines, there's still a long way to go. For others, maybe not so much, but making everything publicly available, shareable, commentable, as Philip said, also like will continuously drive improvement, right? I don't claim at all that our material is perfect, but I hope we will improve this ourselves over future. Plus maybe get input from the students or even some other random guys who stumble across this.
Yeah, that's a good point, especially your differentiation at the beginning between open source resources where you can adapt everything, or just linking lecture videos from other universities, for example, also in our LMU Munich courses it happens, or 3 blue 1 brown videos, because for linear algebra, for example.
Yeah, but I mean, they're genius, right?
Yeah, that's just the go-to. Yeah, exactly.
And it was not to be honest, not my distinction. This distinction comes from the paper or the Ludwigs had, like distinguish between these MOOCs and OER, OSER. This is kind of their, I even don't know if it's their invention or if they just reference it also from somewhere. But I think once I read the paper, I also thought that it's a very, very important distinction, and also make the usability of these materials, makes them usable to a very, very different degree, depending on what your open source.
Yep, that's true. Yep, that's true.
So before another question, just an anecdotal example, the MIT lectures for linear algebra from Gilbert Strang, the first video has more than 4 million views. So there's for sure a lot of hunger for quality materials.
Even more than some music videos, right?
Yes, exactly. But my question would be, what is your personal opinion? How is teaching, university teaching, keeping up with the pace of the field?
It's hard, I would say, right? Because like I'm already excited what will happen at EM, or what the presentations at NLP this year will look like. I guess we'll also experience a lot of new stuff out over there. So, but that's even more of an argument for having everything open source, right? Because then if people feel something's missing, they can just make an issue and say, hey, you should add something on this topic or this direction there. In general, I would say it's hard to impossible to really keep up with the speed that is currently in the field. But if we can try to keep up, then via making everything publicly available and sharing stuff. This would be my take on this.
Also, I saw somewhere, I mean, I cannot quote anything because I'm not sure what the numbers were, but there was a shocking number of what percentage of innovation comes from industry and education, and industry was obviously way ahead in this point today. So this is also an interesting question, how this would pan out in the future.
Yeah, that's kind of also very field specific, right? In the ML deep learning field, it's very much Google and so on. I guess in other fields, it's not so much the case, but yeah, also let's see how this develops in the future. Universities versus some tech giants.
Maybe to that point, do you see a problem between the size of the model and the usability for like even academic labs, for example, but also for students? Because like when we do something, we program Word2Vec or we do the perceptron or something like that, and maybe LSTMs and so on, but that's like sub 10 million parameter models. And like everything currently that's coming on the market is like 175 billion Bloom or, for example, something like that in the range. Is there like, do you see a problem that students or even academic labs, like for example, can't reproduce the paper results or play with the models in a teachable way, for example, because you can build an API to Galactica or something and then enter something and then you can see the result, but you can't tamper with the architecture or do something like explainable with it?
Well, I think the Galactica API was taken down by now.
Yeah, that's taken down, yes. But this was just the last model that came to my mind.
Also speaking from personal experience, this is definitely a problem. I mean, we are in Munich, we're kind of lucky. We have the MCML, which is now permanently funded by the German federal agency, and will thus be there for quite some time. And there's also a cluster attached to this center. So we have quite some compute power, but I guess smaller labs or other labs or even just the Statistics Institute, we don't have so super much compute because statistics comes from it's all about tabular data, and most of the time it's not so compute intense like NLP models. But it's definitely a problem. I mean, as I see what happened to OpenAI, like Microsoft built I think their own supercomputer just for them, and this cannot just be done for some lab or some university. So there's definitely a discrepancy between what industry can do and what universities can do. But on the other hand side, it can also be like challenging researchers to maybe outsmart this trend of getting always bigger and bigger and find smarter and smaller solutions. Maybe I think one nice example is the iPad paper by Timo Schick. He also kind of went, I think the paper was called Small Language Models Are Also Few Short Learners or something like this, where he kind of did some other smart approach using smaller models and achieving similar, or I'm not sure, even superior performance. I don't know, but this is should be the reaction to having not as much compute as others, maybe doing smarter things. And I guess this is kind of a ongoing fight and should hopefully mutually beneficial in the end. So to foster research and make it always better.
Yeah, no, it's just really interesting to get your view because like all our other previous speakers were from Hugging Face, Cohere, DeepMind, Google Brain, and so on. And like they have all the resources available to them. So it's very interesting also to hear the teaching perspective because like, yeah. To reproduce something in that category is not possible right now.
It's even harder. I mean, if you have to struggle finding resources for your research, then getting more of them for teaching is kind of even more of a struggle.
Yeah, exactly. Okay, thanks.
But with industry becoming, or with models becoming more centralized, is it also a possibility that industry might also join in this field because they are also reliant on new talent? I mean, in the field of open source teaching, or is it more that it's more likely probably to compromise the neutrality of science in this way?
Yeah, good question. I mean, isn't it kind of this way in the US already that people kind of who work at Facebook or Google or wherever also, or like take Jan LeCun, he's also at Facebook, I think, or somewhere.
Yeah, Meta.
And he's also, or Meta right now. And I think this is kind of, people from industry are also kind of adjunct professors or whatever at universities. So this is kind of already a mix up to some extent, right? I would argue.
Yes. But is it then also a problem, or might it become a problem that they are trying to sell their own product, since they are then becoming a seller on it?
I guess that depends on the academic integrity of the people, right? And as long as you trust in this should hopefully not be too much of a problem.
Yes, true that.
Let's hope for the best.
Yes.
Yeah, maybe on the optimistic side of things, as you mentioned, maybe if education, just generally academia, I mean, models don't have to necessarily be scaled into infinity. I mean, they can be if you have the computing power and so on, but maybe this is how maybe academia can take back the power, if I can say so. So better models that don't need to be necessarily, because I mean, even universities don't have the resources that OpenAI has, like not at all. And even if you have
I mean, the only option was like doing something like the Big Science Initiative and training something like Bloom on some French supercomputer and so on. It was also a huge collaborative effort, involving Hugging Face to a large extent, I think. Yeah, but I mean, I'm always hoping for smarter ideas to train smaller models more efficiently to perform better. Because in the end, in my opinion, that's not the solution, to just go larger and larger. I mean,
for sure.
So soon we will crack, I guess, another larger model size, but I don't know if that's the final part.
Yep. So if anyone else wants to ask any questions or add something to the points mentioned in the discussion.
Yeah, just to point to the chat, Philip posted the Timo's paper in the chat. It's really a nice read.
Yeah, so everything that we mentioned will link in the YouTube video later, so you can just so people can just go through the description and click through the links. So we'll list everything.
I will just bookmark the discussed link from Philip.
So yeah, if no one else wants to add anything more, I would say thank you for joining. It was a really interesting discussion. Thank you for taking the time.
Yeah, thanks.
And it was really interesting. We'll post it on YouTube, social media, so people can rewatch it and add any comments or ask questions. So yeah, thank you. It was very, very interesting, very nice. And yeah, have a nice day.
Yeah, thanks for having me. Bye.
Thank you.